Greetings and welcome once again to my new calculus channel. I was asked by one of the viewers to explain these new trigonometric functions that are in terms of radical unit angles. So what you see here on the left side are the functions, the main functions, sine, cosine, and tangent, and their inverses on the right side. So let's see how this works. Okay, so well, before we do that, this blue function here is the new sine function, and you see it down here in terms of radical unit angles. Okay, so as you can see, it's not periodic. Okay, and this RA function is a radical unit angle function which takes a sine ratio and converts it into an angle, a radical unit angle. All right, so let's see the derivation. So what you do first is you take the sine function, which is the one that you see down here in blue and the first one that I've written here, and you let that equal to the ratio that you input, this particular ratio here, which is 0.866025, etc. And then you square both sides. So if this is equal to this ratio, I square both sides, and then all I do is I just solve this formula using quadratic equation or completion of the square, whichever you fancy. And since the radical angle always lies in this region, 0 to 1, of course you can have periodicity if you extend to second, third, and fourth quadrant. We have that x will be equal, the angle x, the radical angle x will be equal to this. So the nice thing about this whole theory is that it works in terms of one radical unit angle. And it's easy to convert between angle and ratio, unlike Newton's pretty difficult sine series, etc., which are not even half as accurate as this. So, I mean, here you get the exact answer right away using the formula. Okay, so how do we find this radical angle? Let's see. So we type in, for example, the ratio that we want, which is this ratio here, okay? And then to find the angle, you don't have to do this, but I'm just showing you that if you try to position this line exactly, it will be 60 degrees, okay? So on there exactly. I don't seem to be getting, you don't have to do that, but this is just to show you how it works. Now, if you had a ratio of 1, then it would be the entire angle, 90 degrees, okay? And if you had a ratio of 0, then it would obviously be 0 degrees down here, okay? If you had, let's say, a half, then it would be roughly 40, should be 45 degrees here. No, it should be 30 degrees. I'm sorry, that's correct. It should be 30 degrees. And what would be 45 degrees if we made this square root 2, right? And there you go, 45 degrees. And if we go back to what we had earlier on 0.866025, that's approximately 60 degrees, okay? So that's pretty much it. You can do this same exercise, finding a radical angle formula first, using this equation here, this formula. You don't use the inverse, okay, because that's a different function. So you take whichever, even if you want to find it for the inverse, you would take the inverse function and set it equal to the angle, the radical angle, and then go the other way. And as you can see in this applet here, I've done it with all the ratios, okay? So I start at 0, and I move all the way through to 1, okay? So this works beautifully, very easy, and there's nothing more to it. So I hope that explains to you how this works. I mean, I didn't have to do this trick here where I put it on there. It's just that the radical angle is always this line here, or a proportion of the line. So in this case, it's this proportion, which is 0.89657. Okay, well, I can't be on the computer long, so I'm going to stop here. My name's John Gabriel. Before I sign off, click like, tell your friends about this, become a subscriber. If you have any questions, one at a time, please put them in the comment section, and I'll try to answer as best as I can. Also, become a follower in academia, this site here. Okay, I'll put a link to that, and that's pretty much it. I'll talk to you again, hopefully soon. Bye-bye.